Hello friends, welcome to our channel DSP Math Simple. This video we will discuss about DFT. DFT discrete Fourier transform, that means transforming the signal in time domain to frequency domain. So and reverse vice versa. So x of n is a input signal in time domain, and if we will convert into frequency domain, it is called capital X of omega. In time domain to frequency domain, the process is called discrete Fourier transform. At the same time, frequency domain to time domain is called as inverse discrete Fourier transform. In DFT of signal x of n is called represented by the equation capital X of omega, which is equal to summation of n equal to minus 1 to x of n 0 to small n equal to 0 to n minus 1 x of n and e power minus j 2 pi k n by capital N. Here capital N means number of bits, the DFT bit n, capital N. So the inverse discrete Fourier transform equation is called recovery of x of n. First we will convert the x of n time domain to frequency domain, but at the same time we must recover that so to the original position. So for that we should use the equation x of n equal to inverse IDFT of a capital X of omega, which is equal to 1 by n divided by the number of bits, that is n. So summation k equal to 0 to n minus 1, this x of capital X of omega into e power j 2 pi k n by capital N. Here DFT here represent e power minus, here e power plus. So the equations 1 and 2, that is DFT, IDFT equations, are called Fourier transform pair equations. So DFT of the given sequence can be calculated in two methods. One is direct method, another one is transformation matrix method. In direct method, capital X of k equal to summation n equal to 0 n minus 1 x of n e power minus j 2 pi n k by capital N. So another transformation matrix method, we calculated as capital X of k equal to summation x of n, same equation we are splitting into the two matrix. One is output matrix x of k, here input matrix x of n, then wn of n matrix k of n. So here wk of n represents e power minus j part. This part will be represented as wn k of n. Here wn is called the Dft factor. So Dft factor means it is represented as e power minus j 2 pi by capital N. Suppose for n equal to 4 means we have to calculate, here put 4, so e power minus j 2 pi by 4. So 2 pi by 4 means 1 by 2. So e power minus j pi 1 by 2. So pi by 2 here. So again kn if you put, then you first you apply the n and k values like that. Then another IDFT forms recovery of x of n from x of k. So here same method only. So direct method, another matrix multiplication method. Here transformation matrix method, or another name is matrix multiplication method. So here IDFT x of n recovery is we have to divide the number of bits, that is capital N. So 1 by n into summation k equal to 0, here n minus 1 capital N, x of k e power, instead of minus we are putting plus. So j 2 pi nk by n. At the same time, so here matrix multiplication, here we are converting this x of n, here it is a output, that is recovery of the input signal. So here whatever we find transform in frequency domain, then matrix here. So here it is Dft factor. So w star of this one, this is called conjugative of wn. So here this conjugative means, suppose the Dft factor matrix represented by 1 1 1, here row first column represents 1. So another value is minus j minus 1 plus j. So like that if you calculate, you are putting the values in e power j 2 pi, here e power minus j 2 pi kn. So k value and n value if you are putting 0 to 3, then you will find this matrix 1 1 1 1. First you put 0, everything 0 means e power 0 1. So like that if you calculate row and column, you will get the WN matrix is like this for 4 bits. If you put 8 bits, then same 8 rows and 8 columns, so 8 by 8 matrix you will get. So like that. So conjugative means wherever j values is there, so you can change the position, that is indication plus to minus, minus to plus. So that will be calculated using same e power j 2 pi n k by n. So here n is 4, j 2 pi n equal to k, and putting zeros, n equal to 0 1 2, at the same time k equal to 0 1 2, and then if you get the matrix. In DFT and IDFT, the matrix multiplication method we represented as 1 1 1. This is the matrix. Then input will get the output, capital X of 0, 1 2 3. Here input is x of small x of 0 1 2 3. So recovery of the input signal. So x of n, that matrix represents 0, x of 0, x of 1, x of 2, x of 3, like that, divided by 1 by 4, because I taken capital N is 4. So 4 cross 4 matrix Wn. So multiply with x of n, we will get the recovery of the input signal. Now we will explain the direct method of calculating DFT. So as taken as example, find DFT of the sequence x of n. So x of n takes value 1 for 0 less than or equal to n less than or equal to 2. That means 0 1 2. It will takes values 1, otherwise it is 0. So first we have to write for the total of 8 number of sequences. So 8 number, a capital N they given 8, capital N equal to 8. So small n, x of n equal to 1, 1 for 3, 0 and 1 2 position. So here balance we are putting 5 zeros. So because n equal to 8. So next we formula we have written x of k equal to capital summation n equal to 0 to n minus 1. So that is n equal to 0 to 7. So x of n e power minus j 2 pi n k, here by capital N 8. So we are that is simplification, 2 by 8 we are cancelling, and we are keeping this one, and we are substituting the values n k. So first we are this is the equation. So first we supply that is applying the n values, n equal to 0 to 7. First you apply n equal to 0. So n equal to 0, 7 means up to 2 it is enough, because balance it is 0. So we can leave that one. So n equal to 0. So summation, that is x of n e power j by 8 plus 0 for other values. So I taken like this. So but balance other problem means you must take all the values. So first I am putting the n equal to 0, x of 0, and x of 1 and x of 2. So x of 0 is 1, x of 1 is 1, x of 2 is 1. So 1 into these values, and here 1 into this value, here 1 into this value. So like that I find the equation capital X of k. 1 plus e power j minus j pi k by 4 plus this one, because here 0. So that is the value. So this is the equation. So 1 plus this one, 3 terms only. Now you apply the values k. So k takes the values 0 to capital N minus 1. So 0 to 7. First you put the 0 k values in this equation number 1. So 1 plus e power 0 plus e power 0. So everything e power 0 is 1. So calculate 1 plus 1 plus 1, 3. So like that. So k equal to 1. So 1 power e power minus j 4 pi by 4 plus e power minus j pi by 2. So you put the values, then you will get this equation. So like that, if you put k equal to 2, k equal to 3, k equal to 4, k equal to 5, k equal to 6, k equal to 7, then all the values you take, and within a bracket you write capital X of k equal to 3 comma 1.707 minus j 1.707. This is the second value, this is third value, like that. So totally we got 8 values. So the output x of k, that is DFT of the given sequence 111, we calculated like this. So next we see the that is using matrix method. So compute the DFT of the following sequence: x of n equal to 0, 1, 2, 3. This is capital N equal to 4 bits. So we can use the 4 cross 4 matrix, that is Wn 4, 0, 1, 0, 0, here 0, 1, 2, 3, 0, 2, 4, 6, 0, 3, 6, 4. So like that. So you can see, you can apply the values of dividend factor and Wn power e power minus j 2 pi. That equation you can use, or directly you can remembering these 4 bits of this matrix and you can apply directly also. So directly if you apply this matrix Wn matrix into 0, 1, 2, 3, so if you are putting, so output x of k equal to this matrix, so matrix into 0, 1, 2, 3. So as per matrix calculations, row into column, you put first row and this column, then second row first this column, then third row this column, fourth row this column. So multiply and you add the values, so you will get the these values. So you write in open bracket, that is the output of x of n, that is the DFT of given sequence capital X of k equal to 6 comma minus 2 plus 2j minus 2 minus 2 minus 2j. So like this we can calculate DFT of the given sequence using matrix method. Now we will see the IDFT of the sequence. So first we will convert the x of n to capital X of k. Then we recovery of x of n is called that is inverse DFT. So here question is find the IDFT of x of k equal to 2 comma 1 minus j comma 0 comma 1 plus j. This is the 4 input, but it is the DFT of the sequence. So we should recover the original sequence x of n. So we must go for IDFT. So because we want to find the input sequence x of n, small x of n. So x of 0, x of 1, x of 2, x of 3. So here capital value is capital N equal to 4. So I am dividing 1 by 4. Here this is the Wn matrix. So my Wn matrix I am taking. Otherwise you can use that formula. You can find e power j 2 pi kn by 8 capital N. So you can find each values. So it will time will take. So you can remember this equation, this matrix, then you can multiply with this the given. Now this is the equation as a input. So here 1 by 4 into matrix, here input signal here. So this is the DFT sequence. So here you row and column as per matrix multiplication, and you multiply and add the values. So first row first column, this is second row first column, third row first column, fourth row first column. So you multiply all the values, so you will get 4 4 0 0, and I am dividing here 1 by 4 by all the values. So 1 1 0 0. So I am writing the sequence within a bracket 1 comma 1 comma 0 comma 0. So this is the original signal x of n in time domain. So we recovered the time domain signal from frequency domain signal. So this is the frequency domain signal. So from frequency domain signal to time domain signal, because conversion of frequency domain to time domain or time domain to frequency domain, both will be useful for in DSP processor. Thank you friends for watching these videos. Thank you.